Okay, again, this is basically with section 2.3, but it's really more aimed at the project. This is the collage theorem for iterated function systems. And pretty much the idea here is really all it's saying, the collage theorem, it's a way to design iterated function systems. And so, in a very simplified view, I'm going to, and I'll probably do a video of me trying to do this and kind of show you what happens. But, suppose I want to make the letter F. Now, what I might do, and it turns out this is a little bit too simplified a view, but what I could do is, when I think of the letter F, right, I could kind of think of this block here of the letter F. And to make the letter F, what I can do is take that rectangle and shrink it side to side so it's really thin. And when I shrink it side to side so it's really thin, I get a rectangle that looks like that. And I could also think of shrinking that rectangle a bunch up and down. And when I do that, I would get a rectangle that looked like that. And I could also, shrink it both directions. And if I did, I could get a rectangle that looked like that. And so very naively, we'll find out it's might not be quite this easy. But very naively, I might look at that and say, okay, so if I can do a transformation that simply squeezes this thing together, okay, squeezing by x and y, that would be something like a matrix that, maybe I make it a tenth its original width there, and do that, and then leave y the same, and and take any x y that does that. And notice, that would multiply the x by a tenth and multiply the y by 1, so it would shrink any x values down to a tenth their size. And so if I started with that rectangle, right, I could maybe make it that big. And then actually, if I start with that rectangle, kind of right there, corner 0, 0, I really don't think I need to add anything to make that work. Now, similarly, the rectangle, if I squeeze it up, well, that's kind of the opposite of what I did here. I could go, 1, 0, 0.1 times xy. And you see, when I do that, it'll leave the x the same, but y will be a tenth its size, so that's really narrow. But again, now in this case, though, if I shrink it, it's going to shrink it and put it down here, right? It's going to make y a tenth its height and put it down there. So in that case, I need to add something to it. I need to shift it up. Now, exactly what, I don't know, let's assume it's like 1 or something. Maybe I start with a rectangle that's 1 by 1 or something along those lines. And then finally, to do this part, I kind of need to shrink both, and I need to shrink the y a whole lot more than the x, and so the x maybe is 0.6 and 0, and there's the xy, so I shrunk them both, and I need to lift it up, maybe by a half or something like that. And so it seems to me that if I did that and started with the points for a rectangle, they would go into those 3 spots, And then if I did it over and over, it might fill in really well. Okay, so if I do the video, we'll see that, you know, it's not quite what I wanted. Now, you know, and I can tell you really quickly, there are some parts. An iterated function system needs to be a contraction. And notice that's a 1. And when we do our column sums or row sums, our maximum now is 1. It needs to be less than 1. You know, so maybe I could go like 0.99, right? And similarly here, 0.99. And then those would be contraction mappings. And, you know, and so I might try something like that. And, you know, and that's one idea of the collage theorem, or sort of how it works. Now, with the Fern, okay, so the Fern, it kind of looks like this, and there's a bunch of stuff here and here and here and there and so forth. Now, actually, as you look at the Fern, this is more complicated than just that. It's not a leaf, it's a bunch of things that look like this. And same thing here. And so actually, as you look at a fern, if I simplify it a bit and say that the basic fern is kind of a polygon that does this, so kind of there's the polygon. Then if you look at this, if I shrink that fern and put it here, up in here, so I'll shrink the fern and sort of fill in up there above the bottom 2 leaves with a shrunken version of the original figure. Okay, kind of like the F. I said, well, F kind of looks like a rectangle. Okay, so I create a shrunken version of it right up here, and I place it there. Then I really shrink it more, and I kind of turn it and so forth, and I put the fern right there. But yeah, right, this bottom leaf, if you look at a fern, it just looks like another fern. Oh, that's the idea of kind of the collage theorem, is can I make a picture of something out of itself, right, by shrinking it, going to a copy machine and making various copies of it, using my affine transformation to make those copies just right. And, you know, so I'll scale them, I'll make them smaller, I might turn them one direction or another using things like rotations and reflections and all that stuff we've gotten in chapter 2. And, you know, and so what I'm going to do is I'll place sort of one fern up here, one fern here, but you know, a smaller sort of thing, one fern out here, and actually a 4th fern. I'm going to make a very special transformation where I take the fern and I turn it into a stick, and that will be the stem. And you see then those 3 copies of the original fern I could paste in here to make my new fern. Okay, and so that would take 4 functions in my iterated system. I need an F1 to do that, an F2 there, an F3 there, and an F4 there, or you know, some, you know, maybe this could be F1 and that could be F6. Oh, sorry, it can't be 6. F1 and F2 and F3 and F4. You know, it doesn't really matter which one I say is which, as long as I have them all. Okay, so I could do those 4 transformations to try to create my fern, and actually that's exactly what happens. Is And we'll see in the project how those aspects come together to make the fern. And it's easiest to see if we start with a polygon that's kind of fern shaped to begin with. We can kind of see how the transformations work and how the collage theorem works. Okay, so that's the idea of the collage theorem. It's definitely as much art and nuance as it is technical skill to do these sorts of things. And so it's something that would take lots and lots of practice. I've never really worked with them much, and I've played with it a little bit. I'm not very good at it, but it's a really cool application of matrices, scaling. These the different linear transformations, affine transformations, and recurrence relations. So it kind of pulls all this stuff from chapter 2 together into a really neat little application. Okay, so that's the collage theorem idea.